Hey guys, today we are going to solve some quadratic equations. Quadratic equations are equations in which 2 is the highest power of the variable. Okay, so they come in this form, ax squared plus bx plus c equals 0, where a is not 0. B and c can be 0, but not a, because if a is 0, then this squared term doesn't exist. And then it's not quadratic anymore, it would be linear. Okay, so we're going to solve by factoring, completing the square, and the quadratic formula. And we'll split that into 3 separate videos. So in this video, we'll do factoring, which happens to be the easiest of the 3. However, not all equations can be factored nicely. So we'll start with factoring, and because this is the easiest, this should be our go-to method. And it's really not that difficult to find out when one cannot be factored nicely. And when that's the case, then we'll move on to completing the square or the quadratic formula. So in this case right here, I've got 2 terms. C happens to be 0. There's no C. So what I can do with this is factor out the greatest common factor of these 2 terms. 2 and 7, the greatest common factor is 1. So there's nothing to be factored out there. But this has an x squared and this has an x. I can factor an x out of both terms. And when I do that, I'm dividing both terms by x, so I get 2x minus 7. Okay, so now I'm in 2 factors. X is a factor, 2x minus 7 is a factor. And when I multiply 2 factors to make 0, we need to remember that in order to multiply to make 0, one of the factors I'm multiplying must be 0. So I can find out the 2 possibilities for x by saying this factor equals 0 and this factor equals 0. Okay, so what value of x makes each factor a 0? Okay, so this one is actually done. X equals 0. That's one of my solutions. So if x is 0, then 0 times 2 times 0 minus 7 would give me 0. Okay, now I solve for x here, and I get 2x equals positive 7. And x is 7 over 2. So there's the other possibility. 7 over 2 times 2 times 7 over 2 minus 7 would give me 0. Okay, so here's the value of x that makes this factor a 0. Here's the value of x that makes this factor a 0. Okay, so now I've got a trinomial, and I don't have a GCF I can factor out. I should always look for a GCF first. But here there's a 1, 2, and 63. The GCF is 1, so there's nothing to pull out there. This has x's, this has an x, but this does not. So there's no greatest common factor that I can just factor out of this. But again, that is the first thing I look for always. Okay, so when I've got a trinomial and nothing I can factor out of it as a GCF, I multiply and look for 2 numbers that multiply to negative 63, the C term, and those same 2 numbers have to add up to B, which is 2. So we need 2 numbers that multiply to negative 63 and add up to 2. So for a moment, let's just forget about this negative. What multiplies to make 63? There's 21 times 3. Now, if I'm making a negative, that means one of those 2 has to be negative. Can I make a 21 and a 3, make one of them negative, and have them add to 2? No, so that won't work. Okay, there's 9 and 7. Okay, so what if I turn one of those negative, a 9 or a 7? Can I make that add up to 2? And the answer is yes. If I do 9 times negative 7, I get negative 63, and 9 plus negative 7 is 2. So 9 and negative 7 are my numbers. So my factored form is x plus 9 times x minus 7 equals 0. Okay, so it is factored. Now, x can be anything that will make a 0 for a factor. So I'll set this factor equal to 0, and this factor equal to 0, and find out what x will be. So if I add this 9 or subtract this 9, I get x equals negative 9, and add this 7, and I get x equals 7, and those are my 2 solutions that would satisfy this equation, making this equation equals 0. Okay, here the first thing I look for is a greatest common factor. Okay, so they don't all have an x, so I know I can't factor out an x. But 3 goes into 3 and 24 and 99. So the greatest common factor is 3, so I will factor out a 3. So when I divide each term by 3, I get x squared plus 8x minus 33 equals 0. Okay, so now I have a trinomial here with a lead coefficient of 1, so that number in front of the x squared, this is a 2, that's the lead coefficient. This lead coefficient is 1. I had a lead coefficient of 3, I factored it out. I now have a trinomial with a lead coefficient of 1. So I'm looking for two numbers that multiply to negative 33 and add up to 8. Okay, so again, let's just ignore the negative and think of what multiplies to 33. There's 11 times 3. Now to multiply to negative, I would have to turn one of them negative. So can I take 11 and 3, make one of them negative, and they will add up to 8? And the answer is yes, 11 and negative 3 multiply to negative 33 and add to positive 8. So I have 3 times x plus 11 times x minus 3 equals 0. So there's my factored form. 3 times x plus 11 times x minus 3 equals 0. Okay, now this does not have a variable, so there's no way to make this factor equal 0. But I can set the other factors equal to 0 and find out what x would be. So x plus 11 is 0, and x minus 3 is 0. Okay, so that gives me x equals negative 11, and x equals positive 3. So those are the two solutions that make this equation true. Okay, then my last one here, I have a lead coefficient other than 1. And the first thing I'm looking for is a GCF. Now, they don't all have an x, so I can't factor out an x. Okay, does anything go into 15, 11, and 14? I think the biggest number that does that is 1. So I really can't factor anything out. So there's no GCF to factor out. So I'm going to have to factor this a little differently. So when the lead coefficient is not 1, here's what we do. We take this 15 and 14 and negative 14 actually, and multiply them. Okay, so I have 15 times negative 14, and that is negative 210. So I need my two numbers to multiply to negative 210 and add up to 11. Okay, now an easy pair that multiplies to 210 is 21 and 10. Can I make one of those negative so that it multiplies to a negative and adds to 11? There's 21 and negative 10. So 21 times negative 10 is negative 210, and 21 plus negative 10 is 11. Okay, so my two numbers will be 21 and negative 10. Okay, so when I factor this, I'll start with 15x squared. Then I'm going to take this 11x and I'm going to split it up into 21x and negative 10x. Okay, so all I've changed is that the 11x is now 21x minus 10x, which equals 11x. So I haven't really changed anything but the look at this point. And now I'm going to factor by grouping. So I'm going to take this first set of terms here, these first two terms, and see what I can factor out. And I believe I can factor out a 3x out of these two terms. Okay, so a 3 and an x. So when I divide 15x squared by 3x, I'll have 5x. And 21x divided by 3x is 7. Okay, so this next set of terms, and I need to bring this sign with it. When that's a negative, I need to factor out a negative, and the greatest common factor then would be 2. So I can factor out a negative 2. Negative 10x divided by negative 2 is 5x, and negative 14 divided by negative 2 is positive 7. Okay? Now, both of these terms have a 5x plus 7. So I can pull that out of both terms. And I'm left with 5x plus 7 times 3x minus 2 equals 0. So it is fully factored at this point, and now I can set each factor equal to 0. So 5x plus 7 equals 0, and 3x minus 2 equals 0. So that's 5x equals negative 7, and x equals negative 7/5. Okay, so there's one of my two solutions. Okay, and then 3x equals 2, so x equals 2/3. So those are my two solutions.